Do you have the patterns in your book as well? RabbitMQ.
Yeah, there is a chapter explaining like RPC, publish, subscribe, topics, and so on. Chapter 4, maybe.
No, the advanced patterns you covered.
No, because it would be, I guess, too much for this book.
In terms of like on the server side, to get the most kind of performance out of obviously, you probably want to run it in a fire and forget mode. Is that kind of the most normal way to run it? Or,
I mean,
in terms of queuing, it's quite effective anyway, even if you're using kind of acknowledgements and having the server waiting.
Yeah,
I was kind of thinking from the point of view, just to give you honest, more like around things like Mongo, maybe things that when people are using that to get them, really good performance, it's fire and forget.
I mean, you can do that with Rabbit, and the problem, I think, I don't know, for what I read online on this Mongo architecture, it's like you're constantly polling the server to see if there's new stuff, probably, like each, I don't know, what amount of time. And in the case of MQP or Rabbit, it will push the message as soon as there is a new message, but you're not bothering the server, like treating it like a database, so it would be more like events kind of place.
Yeah.
So then, yeah, if you do fire and forget, and you don't acknowledge the messages, that will be really fast, because actually the RabbitMQ code, it will do an optimization that says, okay, this queue has a subscriber already, which is not acknowledging messages, so why should I write the message to the queue when I could deliver the message directly right away, and if it's lost, not a problem. Which is what you are doing when you do no ACK. So that will happen. Then, depending on the kind of message, if it's persistent or not, Rabbit will write the message to disk, and depending there, to which, I mean, RabbitMQ underneath has two message stores. One is transient, and the other is a persistent one. So the transient one, whenever RabbitMQ boots, this one is erased because there was a reason why you were publishing messages in non-persistent mode. So yeah, why should the server care about that? So this is wiped out. Yeah, I think that's you will have like no hacking and like transient queues, and that's how you will try to get the most out of it.
So people use it in production in a variety of these places, or is it more prevalent in the fire? Do people use it more for the fire and forget way, or do people use it?
I think it doesn't matter. It depends on what you do.
The use case, really, yeah.
For example, in this computer, if you go to hacking messages, you will drop to 4,000 a second.
Oh, okay. Yeah.
Yeah, for example, once I read a discussion from January this year about Twitter size or Twitter scale, and I remember the amount of messages. Of course, Twitter, for each tweet, will probably do a lot of processing. I'm not saying it's not the same use case, but people say, no, it's RabbitMQ Twitter scale, but 4,000 messages per second or 12 in this computer, you just do the math, it's like 1 billion messages per day or something. So it's still a lot. I mean, always depending on your side. I know in Switzerland, the guys from a bank, an investment bank, they use Rabbit. I know some guys that do book betting online in the UK. By UK, I mean England. They use RabbitMQ for that. Then the guys from ETH, which is this university in Zurich, they use RabbitMQ for predicting earthquakes, and they're building a system all around that. Then NASA has it in OpenStack.
BBC is using it for tweet processing, also at the big level.
So I think there is, I believe it's fast enough. But maybe some people, I have an Irish friend from that part of the UK who used to say that he's in the negative microsecond latencies. But yeah, it's just a joke. So, any other question? Yeah.
Yeah, so RabbitMQ is broker based. So while it allows loose coupling between systems, it's still separate server. So
yeah.
Another competing alternative to that is kind of a distributed messaging system where, say you've got two sites that are connected via a weak network link. You write local, but the services might be on either end. Does RabbitMQ have built-in capability that for bridging So if you want to write to a queue, well, the services on a different site, you kind of write local, then it goes to the far site, it will be handled remotely, and then they will write local, and it comes back. Does RabbitMQ that built in, or is that?
No, you need to do it yourself. You probably need to run a RabbitMQ on each of these machines. You could do that, and we'll do all the queuing for you. But whenever you know there is a link you can synchronize.
For both systems, they just see one service bus, as it were. But
I mean, you can use, for example, clustering, but I don't think that's what you mean exactly.
In service bus and mono service bus will be the alternative. That's their distributed mechanism. So there's no central hub.
Yeah.
So there isn't a single point of failure, even with clusters.
Then, like, you can also, there is a plugin called Shovel for Rabbit.
Yeah.
So if you have separate locations, I mean, the network, you can send to one Rabbit, and then the messages will be routed to the other one. You can do that, and yeah, that is, I guess most of the time you have to do stuff yourself.
Right.
So I think, for example, you can do it with ZeroMQ, but on ZeroMQ you don't have the real queuing, so if something crashes, poof. So you have super speed, but I think in those cases the best is always to mix solutions. So, like for some stuff you use ZeroMQ, there is a RabbitMQ plugin for that. So you can publish on a ZeroMQ socket and also get the messages on RabbitMQ, and vice versa. So, yeah, I will go for something mixed. But there is nothing, I think, in the server right now.
And the messages persisted if the call goes in?
Yes.
Like, is it persisting as it's receiving the messages?
Whenever you publish a persistent message on a durable queue, the protocol specifies that the message must be written to disk. If then there is a fire and earthquake in Japan, that of course goes out of the software or hardware contract. Yeah. Up to that point, you are sure it is there. So if you can get the server back up, you should be able to get the message.
The best argument for that is to have your system and services in the same locality as RabbitMQ, around the same lab.
Sorry?
You don't want to have a situation where, say, RabbitMQ is inside your London office and you're trying to write to the RabbitMQ from your New York office or SDN. You know, it's when the file system goes down, you can't continue to write messages to your queues. And that's what I was asking about the distributed mechanism. You want to write local, but then bash them across and the lines live.
Yeah, I think if you need to not lose any message, that's
two sides.
I mean, the other day I was telling Andrea, I went to the CERN and they're also building like a huge computing grid, and they are using RabbitMQ too. And also ActiveMQ and Apollo, there is a new one I heard about, which is a new ActiveMQ written on Scala. And yeah, they really need to have all this kind of write it here, send it, synchronize, and we were like discussing like 6 hours trying to see what is the best way to get that. So I don't think it's so simple to solve. Yeah.
More generally, what do you think are the pluses, and if you don't mind, the minuses of RabbitMQ compared to the other major open source message queues, some of which you've mentioned?
I don't have that much experience with the others, so I would like to not comment about it.
What are the selling points of RabbitMQ then? What do you think are its big advantages in that case?
For me,
or disadvantages?
What I know of is like the community is quite active, there is good documentation. For example, in the NQP library for Ruby, I know Michael is doing a great job adding more docs. I don't know if there's more people involved. I know about Michael. And I think the developers, they reply quite easily and fast in the mailing list, which is a plus. Like you are blocked with something and then you are not waiting a month till somebody tweets something. So in that sense, I mean, the support in the community I think is good. Then the server is reliable. I mean, unless you do something, for example, if you overwhelm the server with messages, but really like you overwhelm it, every system will crash or slow down, or I don't know. So, but at that point you have a capacity problem, a capacity planning problem. So maybe you need 2 servers, which will happen with MySQL, will happen with whatever, with Apache, Nginx. So if you plan that, I mean, for this website, in this Data Insight, we were using it. The only way, I mean, we shut it down when we did the upgrade, but not because it crashed or something like that.
If I may also, I think RabbitMQ has really a lot of plugins, so that's definitely an important reason for me. And like for example, there's management plugins, so you can see how many messages you have, how many queues, and so on. And also it's going to be supported on Heroku and Cloud Foundry. Actually, it is already supported on Cloud Foundry, and it's on, I think, beta on Heroku now.
And the plugins will that kind of be something that sets you apart from other queuing systems, probably. Yeah? The number of plugins.
Yeah,
the community and-
there's really so many plugins. I don't think.
Yeah, for example, Stomp, this other protocol, which is way simpler than NQP, but I mean, it's simpler and the concept, but at the end you end up reinventing NQP because you need to have a destination, you need to have acknowledgement, I mean, there are stuff that at the end you will build on top of Stomp. Anyway, Stomp was not supported by default on Rabbit, and then there was a plugin, which is, now you can have Stomp on the server. Then I know there are the JSON RPC server, so I think you can publish messages using JSON on some REST interface. And I mean, if you know Erlang, it's really easy to extend. And for example, it's a big if, but the Exchange API is to implement like 4 or 5 methods. It's really, really simple. And Erlang is very succinct, I think is the word. So, for example, to route the messages differently, you implement everything as default in this interface, but the route function, you do something that you may want to do. And that way, with a basic reading of Erlang, is what you will get it running. For example, I wrote a sample chat application for Rabbit, where each client, each user had its own private queue. And the problem in a chat system is that when you connect to the system, you want to get some context of what's going on, like the last 20 messages or something. RabbitMQ doesn't support that, because every time a message arrives to the queue and it goes to a consumer, it's gone. There's no. So I added an exchange, which was called Recent History Exchange, which kept in memory a list of 20 messages, like a circular stuff. So every time there was a new message, it was added to this list, and the last one was dropped, and so on. And whenever there was a new binding, it meant there was a new user arriving to the system. So I did the binding and then sent all this list to that to the queue of that user, so the user got the context. And that was, I mean, really nothing to implement. And you can have your own queues, you can have your own authentication methods. So if you are not happy with no SASL support or whatever, you can have your own way based on your user database list or whatnot. So yeah, I think the plugins is a big win in Rabbit.
So that's an enterprise situation. Things always have to be integrated. So you often want to plug into a whole bunch of systems, and so that you can queue things off, and then have plugins as well to join into them all. It's quite useful for a business or enterprise trying to integrate a lot of things. Like the wiretap one was interesting, where you can keep an eye on the queue as the queuing messages are going through. I suppose, do you find with an open source project like that, obviously a lot of your people you're talking to are enterprise based, do you find that a lot of people are kind of big businesses and companies, or do you find people doing smaller open source projects using it more, or is it a mix, or do you find one more than the other?
I mean, first I don't work with the RabbitMQ guys to know that much, so.
Oh.
But I've seen, yeah, it's used, I think it's used everywhere. Or probably, yeah, maybe in the open source world when you need a queue system, you just go right away from Rabbit. And maybe like in a big corporate, I don't know if you can just say RabbitMQ. But for example, Apple last week was looking for RabbitMQ.
Yeah.
So I know that they want to build this system to log everything through a message broker, and the description asks for RabbitMQ spirit. So
we got a demo for a message broker called Neuron ESB. It's $25,000 per core. Government queues from an enterprise level, there's a lot of features. And then there's just a sudden massive jump to typical Neuron ESB where you have to ask the price, you can't afford it. As simple as that. So with the amount of features you get this, it's near enough.
Yeah.
To the enterprise stuff.
a bit cheaper.
So two questions for you, right? One is the scalability. If you want to have to send a lot of messages to your worker, you want to cluster something, right? So how would you handle it? If you have a lot of clients, a lot of consumers, then you want to have machines to handle it. And second sort of tied to, what's the high availability of failover state? Is there like a simple way to achieve something like you send your message to a broker and you have guaranteed that it's going to deliver it, even if one nodes and lots of fails or something like that.
So what we used to do in this dating site, for example, was to have 2 RabbitMQs, and then on front there was a Linux virtual server, so all the producers were sending messages there, and then the messages got distributed randomly, of course. And then we had, for QA, there was 2 consumers, one connected directly to each of those servers. So in that way, we achieved what happened if some RabbitMQ crashes or is down or I don't know what. So that's not actually clustering, but it was what we did and what was enough for our requirements. Then, RabbitMQ supports clustering in the Erlang sense of clustering. So that is made mostly for supporting many users, but not for high availability. So in the case of RabbitMQ, the messages, as I said, are persisted to disk based on this custom database that RabbitMQ has. But the queue information, like the meta information of the queue, like the name and so on, the exchange information and the bindings are all kept in Nisha, which is the Sept database, which supports clustering by default. So all this information is distributed on this cluster, and then all these servers are treated as one. Then on the RabbitMQ website, there is a description of how to do HA using the RBD, which I don't have experience with that. And of course there you will trade speed for reliability and so on. And now since the latest release there is the mirror queues. So when you declare a queue, you say that this queue has mirrors in the certain cluster. And even if there is, let's say you say it will be in node 20, but node 20 is not available yet. Whenever node 20 comes up, the server will take care that a queue get mirrored there, and it will handle the responsibility for this queue. So that is what I know of. Maybe there is more, or people doing other stuff. I don't know. Any other questions? Yes. Oh, she's reminded me. The guy from RabbitMQ kindly gave us the T-shirts. So I guess, I don't know how we can give them away because we don't have enough. But maybe you can find with a hurling bat here. I don't know. Or while you drink beer, we can take each bar's name and then do kind of a raffle. And
I can't believe you've actually avoided the temptation to make some sort of queuing joke.
yeah, then run Ravi into it. So yeah, we have t-shirts, and I can show you. So you get these ones. So maybe while you drink beer, we decide. And then the guy from Manning also say they have one free ebook of this RabbitMQ in action book, and once it's published, you can get access to the EPUB format and whatever online version format they use. Finally, in this video, I have some videos, tutorials how to create plugins and stuff for RabbitMQ, and the slides are many versions of the conference, many versions of other conferences I have there, you can find there. So, thanks.
Oh, by the way, I have some stickers, so if you want some RabbitMQ stickers,